Have you ever heard of the infinite monkey theorem? Maybe yes, maybe no, but let's clarify. This theorem suggests that if monkeys randomly hit keys on typewriters for eternity, they will eventually produce every possible text, such as the Lord of the Rings trilogy or even this script. Since we can't afford real monkeys, imagine each Pedro here as a monkey. This thought experiment helps us explore probabilities and their fascinating implications. But why would anyone come up with such an idea? Because probabilities are one of the most intriguing yet counterintuitive tools in mathematics. Think about the odds of a monkey typing Game of Thrones. It's astronomically small, right? Yet, in an infinite universe of attempts, it's not just possible, it's guaranteed. This paradox shows how the improbable can become inevitable under the right conditions. Let's go further. What are the odds of a monkey typing the letter E infinitely? Technically, it has a 0% chance of happening. Yet, it's not impossible. Strange, isn't it? Welcome to the world of infinite probabilities, where events that seem impossible coexist with mathematical possibilities. This apparent contradiction can be explained through infinite probability mathematics. When discussing specific events within an infinite context, such as a particular sequence of letters, the probability is technically 0%. However, if we broaden the scope, say, finding an entire trilogy within a random infinite text, the probability becomes greater than 0%. Calculating it, though, is an incredible challenge. One fascinating example of this is the Library of Babel, an online project simulating infinite random texts. You might find sentences like, "Subscribe to this channel and like the video." Isn't it amazing that, given infinite time, even the most improbable phrases can appear? It's almost as if the universe conspires for you to watch this video until the end. Let's leave monkeys behind and talk about the lottery of life. Have you ever stopped to think about how unlikely it is that you were born? In a single act of conception, billions of sperm race toward one egg. And that egg had to belong to a specific woman at a specific time in history. Every detail of your existence is astronomically improbable, yet here you are. Now consider DNA. Despite all biological diversity, it's all built from the same four chemical bases, A, C, T, and G. It's fascinating to realize these combinations create everything, from humans to bananas. Yes, you share 20% of your genes with a banana. But in humans, the number of DNA combinations surpasses the total number of particles in the universe. This leads to a profound thought. Are we truly special or just one of infinite possibilities in the cosmos? Perhaps we are winners of a cosmic lottery. Even if that's true, the odds of someone exactly like you existing are so minuscule they almost defy logic. But odd probabilities don't require infinite scenarios to confuse us. Have you heard of the random walk? Imagine taking steps left or right decided by a coin flip. After 1,000 steps, where would you be? This concept applies to everything from particle movement in the sun to human behavior models. Take sunlight, for instance. It doesn't travel straight out of the sun. Inside, it's absorbed and re-emitted billions of times in random directions. This journey can take hundreds of thousands of years. The same principle governs how particles behave and even helps us understand key materials like plastics and semiconductors. Speaking of randomness, let's debunk the law of large numbers. If you flip a coin 1,000,000 times, it will average 50% heads and 50% tails. But that doesn't mean you won't see long streaks of heads or tails. Probability is full of fascinating quirks like this. Another intriguing example is medical testing. Imagine a test that's 99% accurate for a rare disease. If you test positive, your actual chance of having the disease isn't 99%, but closer to 16%. This happens because rare diseases produce more false positives than true positives. This concept, explained by Bayes' theorem, is critical in understanding real-world probabilities. These examples show how probabilities, even in everyday life, can be misleading. For instance, the average number of human legs is less than 2 because some people have fewer legs. Yet the median number is 2, as most people do. Statistics are powerful tools but require careful interpretation. Finally, I'll leave you with this thought. In an infinite universe, Could there be versions of you making different choices? This blends probabilities, physics, and philosophy. And since probabilities always surprise us, what do you think? Share your thoughts in the comments, and don't forget to like and subscribe for more fascinating